Good morning, everyone. I'm Vinita, working as an associate professor in the Department of Electrical and Electronics Engineering, R&D Engineering College. Today, I am going to discuss about lightning protection of transmission line in power system transients. Today, there will be various methods are available for the protection against lightning. So, lightning, we have lightning arresters, we have ground wires, ground rods, and many more methods are there. And this transporting resistance, which is one of the methods used there to provide protection against lightning. And let us see what is meant by transporting resistance. So, it is a resistance offered by the transporting to the dissipation of charges to the ground. So, as we know, the purpose of resistance, which is used to discharge whenever any faulty condition occurs. Similar to that, here also during this lightning process, there will be heavy discharge of heavy discharge of charges, and that discharge that will be taken to the ground through this downputting resistance. And this downputting resistance, which is an important parameter that decides the effectiveness of the transmission line. That is how how during this lightning process all the charges that will be taken into the ground, and how the protection how we are protecting the transmission lines. And the soil characteristics, which is one of the major effects that affect the value of the outputting resistance. Therefore, due to various soil types and subsoil structure, different types of electrode arrangements, uh, these are all the main factors that will decide that outputting resistance. So when a lightning strikes the transmission tower, a traveling voltage is generated, which travels back and forth along the tower, and these waves it may be reflected or refracted at the tower footing and at the tower top, thus raising the voltage across the cross arms and stressing the insulator. So what will happen whenever the voltage that will be travel along the transmission line, these may be increase the voltage level, and therefore what will happen? The the increase in voltage that may affect the insulator. So the insulated would flash over if the transient voltage exceeds its withstand level. So the effective ground wire that depends to a large extent on the downputting resistance. So you know about ground wires. It will be provided at the top of the transmission tower. So the purpose of providing this ground wire that is again, this is used to protect the transmission line only. So if we provide the ground wire that will be discharged all the charges to the ground. So the tower top potential depends upon its resistance. What is the significance of the downputting resistance? The low value of downputting resistance results in less voltage stresses across the line insulation. A downputting resistance of 20 ohms is used for extra high voltage transmission lines, and 10 ohms that will be used for high voltage transmission lines provides sufficient lightning protection. And here, the value of the formula to calculate outputting resistance is given here. So RT is equal to RG divided by square root of 1 plus I divided by IG. Here, IG is the current limiting current initializing soil ionization. And here, the formula to calculate IG is given 1 by 2 pi E naught into rho P divided by RG square. And here RG is nothing but outputting resistance at low current and low frequency in ohms. And RT is the outputting resistance. And I is the current, surge current into the ground, which is given in terms of kiloamps. And rho is the soil resistivity in ohm meter. E naught is soil ionization gradient, and it will be about 300 kilovolt per meter. And while designing this outputting resistance, there will be various types or there depends upon its arrangement. So the types are hemisphere, vertical driven rod, carried horizontal wires. And here that electrode shapes and corresponding formula to calculate resistances are given. For hemisphere, the formula to calculate resistance is rho s divided by 2 pi r. For vertical given rod, it is rho s divided by 2 pi L into ln of 2L by A. And for horizontal wire, the formula is rho s divided by 2 pi L into ln of 2L divided by A into 1 plus ln of L by Y divided by ln of 2L by A. And here the various shapes are given here: hemisphere, vertical given rod, as well as horizontal buried wire. So this is otherwise called as counterclockwise wires. In the staff footing resistance that depends upon the factors like type of electrode configuration employed, soil resistivity, and electrode shapes. So these staff footing resistance, which is used to reduce the earthquake potential and stress on insulators at the time of stroke and for safety purpose also. This staff footing resistance will be in the range of 10 volts and should not be more than 20 volts under any condition throughout the year. The earth resistance that depends upon soil resistivity. So the value of soil resistivity in and around 100 volts per meter. So this is about outputting resistance.